Okay, so I had a power glitch, I guess, or something. My whole computer shut down, and I am not happy about that. But anyway, let's see what happened. So go to agent in Docker terminal. So C dash launches a container. Okay, so we go to 5 grim list array dash resume. Okay. Okay, now create another one. Okay. Okay. All right. Go back to GitHub. Dojo 5. Okay. Okay. Oh, my read server's not running. Oh shit. Okay, no big deal. Read server. So I can was I premature on these guys? Are they going to be able to? This token is required. Shit. 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 So after this guy finishes, I'm going to quit and do set env BS token commit. Okay, so he's committing. After he's done committing, I'll oh, but he's not going to be able to close that. Shit. BS resolve. Oh shit. Token is required. Shit, you can't do anything. Right, I'm gonna. Oh, Control C doesn't work. Damn it. Okay. Echo. Echo. Okay. Port. Yes. Token. Let me see what. Echo. So you're gonna be able to figure it out. It's just trying. Oh, poor guy. Shit. Okay, he's got it. Okay, he's got it. Cool. Okay. So what was I doing? I was what was I doing? I was having a conversation about read all the workflows. Okay. Okay. I want to set up a workflow similar to VS Work, but I want multiple instances of array in parallel. Not a single instance that uses but run each instance from a directory with a separate checkout for the project. I want each one to do its work and commit, but I am going to need a merge rebase type of workflow. What I am thinking is this. Each, if the remote is not ahead of me, then just push. If the remote is ahead of me, then rebase and fix any merge conflicts and try again. If during the rebase, the remote may again get ahead of me, in which case I'll rebase again. Does this make until at some point the remote is not ahead of me, and then I'll push. Does this concept work? What am I missing? What do you think of this approach? And the good thing about this, or if I've done a bunch of work and it's in the context, and then the remote has changed some, and I do a rebase, then because I know what I've done, what my task is, and all the work that I've done, the rebase should be somewhat straightforward, as opposed to a third party trying to do the merge, um, trying to resolve conflicts. Anyway, that's the idea. So, and I think if I can launch independent things that have no knowledge of each other except for they're coordinating through the bead server um, to manage who's working on what, and then they're also um, and then they're also uh, communicating through the remote as far as who needs to rebase and all that kind of stuff. And so it should be scalable to uh, number of workers. Okay, what do you think? What works well? Each instance has one directory and file system contention. The server naturally partitions work. No two agents claim the same task. Rebase loop will converge as long as agents aren't pushing faster than any one agent can rebase. Don't check then push. Just push and handle failure. Proposed. Okay. Okay. Fetch rebase push. If loop if succeeds done. Okay. Okay, let's create new folder, PS work multi, and start a document human readable, not array state, not array state. Read that captures the intent in your updates. Okay, how's Raymond doing over here? One start. Oh, no, already committed again. Schema migrations. Okay. Mictar-P. Okay. I think I'm gonna. No, accepted. It's okay. Go here to workflow samples, PS work multi. Okay. Yeah, just push and handle failure. That's better. Retest after rebase. This is a big missing piece. Yeah. Yes. Put retry cap on the rebase loop. There's a loop which converges. Mark the task as needing human attention. So another approach is, instead of mark the task as needing human attention, is to throw away all the work that you've done, mark the task as ready, and abandon it, and then someone else can pick it up with a fresh. So I guess the other thing is pick it up with a fresh remote and start work anew. So that would be interesting. Okay. Independent Raymond instance in parallel, each in its own directory, separate checkout project. Each instance claims a task from the beat server. Claim task, implement, review, commit, push, resolve, and claim the next task. Run instance currently create soup. Each instance is fully independent, no shared state, no Raymond level coordination. An important coordination is the git remote. Each instance runs its own directory with its own git clone or work tree of the target repository. Each instance runs its own RAID process with this workflow. Beat server handles task partitioning. No two instances will claim the same task. All instances push to the same remote. Okay. Check workflow per instance. Check fix commit. I don't see. Oh, the arrows are all messed up. Check fix again. Commit push loop fetch rebase. Fetch rebase. Clean rebase. Retest push. Push loop. Resolve task. Conflicts. Resolve conflicts. Retest. Rejoin push loop. What does that mean? I guess that means go back to push. Okay. Okay. I like your document. I'm a little here after push loop. Yeah. Okay, good, good. Try push. Mm-hmm. BS resolve, then back to claim task. Okay. Rebase loop at push time. Let's see how this guy's going. One start. Okay, so he fixed another one. Close at 7. Okay. After committing locally, instance enters a push loop. Get origin, get rebase origin main. If rebase is clean, retest to catch semantic conflicts. Push is rejected, go back to step 1. Okay, how would the retry gap be implemented? Also, I'm thinking when the read gap is hit, the agent could throw away all its work and mark the in progress task as open. Then another agent, or the same agent, could start with a fresh copy of the note and begin new. For definite. Okay. All right, so Raymond is crunching along. Oh, committed another one. Closed 8. Okay. How's Raymond? Okay. Oops. Okay. 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 How are we doing here? 27 closed. 29 closed. Okay, I guess just running Okay. Good call. The outer call is over engineer. Resolve task is just before BS resolve and transition. It doesn't need the implementation context restored. No, it's complexity of extra call boundary. Okay. Inner isolation is where the real value is. Okay. Simplify the context management section. Okay, go to resolve. Okay, commit push gate. No session, $0. Overcap bailout claim task. Undercap call push gate. Sort of call return push gate. And push isolates each attempt. When the call return goes back to push gate, mm, when push when the um, fetch plus rebase might be clean or it might be a successful merge or it might be a conflict. If it's clean, then just push. And if push is success, then we're done. If rebase is success, merge, and conflict, then we test and push. If push is success, then we're done. If rebase is merge, then merge conflict needs, then resolve merge conflict, and retest and push is success. And we're start over with fetch rebase. Merge format the conflict. This is not the hook for that dependency. So as far as call return, this would be in the this is not considering call return context. Okay, close 12. Each of these items is maybe 3 to 5 minutes. Looks like 10 minutes, 2 minutes. Good call. You ought to call. Oh no. You're right. My workflow was wrong. The key distinction I was missing is that 3 rebase outcomes, not 2. Clean, already up to date. Nothing to play, just push. No retest needed. Merged, retest then push because semantic issues could exist. Conflicts, then resolve, retest, and push. In all 3 cases, if push is rejected, loop back to fetch rebase. Let me redo the diagram and description. Now update rebase loop. Okay. Okay. Push gate. How many times have we tried to push? Undercut. Fetch rebase. Fetch rebase route. Clean, then push. Merged, retest, then push. Conflicts, resolve conflicts, retest, push. Push. Success, resolve task, claim task. Rejected, push gate. Yeah. Okay. Call return result. If fetch rebase call was to fetch rebase and the result went to push.sh. Call does not recall that call has 2 destinations. One branch for the branch to be discarded and another for the subsequent state. fx. All right. Oh, it's still thinking. Okay. That's a much cleaner design. Let's think through it. Call, return, push, fetch, rebase. Call branch is a disposable part. All the rebase noise conflict resolution retesting happens in an isolated session. Return destinations where control lands after result. With the isolated session discarded. All three paths end with result. Clean merged. Okay. Okay. Push gate. Call branch. Fetch rebase. Clean merge result to okay. Push gate uses call return push fetch rebase calls disposable part. All three paths emit result. Push gate fetch rebase push sh. Shell scripts only resolve conflicts retest. Okay. Okay. Add updates section 5. Okay. Okay, so I'm like a third done. God damn it. Yeah, my typing is terrible. So the orchestrator is Raymond. Let me find Raymond. Oops. As my repositories. Flow samples. So I had, yeah, I hit my limit. Damn. So this is Raymond running, where it's crunching through this backlog of. So I also have a backlog of. This is my issue tracker where I created 23. No, there's like 32 issues, and it no 30 what 37 issues, and I was crunching through them and committing to. So you can see here on Dojo 5, it's been uh, crunching for like an hour crunching through the issues, and then while it's running, I was also because it's basically just waiting for it. I was also thinking, oh, this would be a good opportunity because the hope is that sometime I would be able to. So this BS work is basically, take an issue from the issue tracker, work on it, check if there are anything better, any improvements that you can make, and then when you don't find anything more worth fixing, then commit and move on to the next commit, and then move on to the next uh, go back to the start, pull the next issue. So the what I'm doing with Dojo 5 is just running this workflow, this BS workflow. Um, the but what I want to be able to do is with this issue tracker, you can see if there are multiple, um, if there are, shoot, let me start a new one. If you have multiple items that can run in parallel, uh, um, BS uh, list, list ready. So there are 4 tasks that are unblocked. So it'd be nice to be able to run multiple in parallel, but then have them commit and merge and do the rebase from the origin. So anyway, that's a summary of what I was going for here. It looks like I have to take a break because I've hit my limit. Um, so when I so 1 o'clock local time, I guess I will resume. So the so as far as the BS work multi is that so the idea is each agent wakes up and then works. Each agent goes through this workflow of going from one prompt to another through this kind of finite state machine, and it can branch and do this kind of stuff. This is kind of the point of Raymond, um, is to be is to do this kind of uh, structured structured finite state machine that goes through this using Cloud Code to execute each state. So claim task, implement, check if there's anything worth fixing. If there's nothing worth fixing, then commit. If there is something worth fixing, then fix it and go back. And so this part here is basically what BS work does. Now what I want to do is be able to run multiple instances of Raymond concurrently, each in a separate folder, each has a separate checkout, and then they'll resolve themselves through the remote. So one will, so the idea is, um, so first, uh, and this is what I've been talking through the LLM to try to decide, how this is going to work. I want to, um, so there's an outer loop counter that will limit how many times it can try, and if it tries more than 3 times or something, then it'll bail. But so it'll do a check if I've done it too many times. If I haven't done it too many times, then I'm going to do a fetch and a rebase, and if it's clean, that is if the head is not ahead of me, then I will push. And push, if it's successful, then that closes the task, and then I'll go to the next task. If the if the fetch and rebase is a clean merge, that is, there are no conflicts, then I'll rerun the test because there could still be some, the remote code, even if there's, anyway, rerun the tests. And if the test, I guess I don't know to what point does the test go back to the implement. I need to think more about this because the retest, this might not be appropriate. Uh, well, maybe if the retest fails, then there needs to be a branch to go to a different state. But anyway, if retest is successful, then push resolve. If resolve conflicts, retest. If that's successful, then go merge. And so the idea is they'll kind of race to see whoever pushes first gets the gets to not have to rebase their changes. Then if some other agent in parallel does the fetch and rebase, then oh, this is uh, I've got a conflict. I need to rerun the test and then merge. So hopefully it's sort of like multiple employees, hitting a common remote. They generally have to pull, rebase, merge, and then push. Um, and I don't, I mean, you could do branches and then have somebody, into a feature branch and then have master or some kind of authority do a pull requests and all that kind of stuff. This is sort of so I'm choosing not to do that. I'm instead just keeping everything on main and doing a rebase instead of a branch and merge. So by doing a rebase, the final uh, Git history will look like just a single linear sequence of commits. And then if you're doing work and someone else changes it out from under you, your responsibility is to make it look like it's been added onto merge, added onto the main. So anyway, that's the so here we are. So this guy's now stopped. He's gonna um, yeah. So anyway, I will. All right, I guess I'm going to stop and maybe I'll resume in an hour. Maybe I don't know if I'm going to come back to this today, but anyway, that's where we are. So I'll see you guys.